Hi guys, and welcome back. So in the last video, we went ahead and set up our namespace called net policy. So let's actually maybe just change that in the diagram here so it matches up. And then we've got a pod here called MySQL server, and we set the label on it called purpose equals DB server. Let me actually just double check. Yep, purpose equals DB server right there. So now what we're going to do is spin up a second pod in this namespace. However, we're going to make it interactive, and then we'll attempt to connect the MySQL client over to the MySQL server. And think about it, by default, that connectivity should actually work because we have not yet implemented any network policy rules. And by default, all of the pods in our cluster are going to have access to communicate with each other. So we should not have any problems communicating to this pod, but let's just confirm that using our kubectl command line. So we'll fire up our kubectl command line here. Let me actually just do cd /, free up some screen real estate. So we'll do a kubectl run, and this is going to be an interactive container. So I'm going to do standard in and then tty as well. And that's going to ensure that this container is interactive, so I can type into it and actually see the standard output from the container from the pod in real time. And then we need to specify an image here, and I'm actually going to use the MySQL image. We're going to use the MySQL latest image here. And that's because the MySQL image, even though it has the MySQL server, the daemon, installed in there, I also have the MySQL client installed in there as well. So I don't have to run any extra commands in order to install the MySQL client into this container. Something else that you could do is just use a Ubuntu latest image here as well, but then you'd have to use the apt package manager to actually, do an apt update and then do an apt install on the MySQL client tools. So it's just a little bit of a time saver to just use the MySQL image. However, we're not actually going to run the default command in here. We're actually going to override the command or entry point for this image so that we're going to run a bash shell instead of firing up the MySQL daemon. So now we need to give the pod a name. I'm going to call it MySQL client, and then I'll do a -- here and specify my entry point, which is going to be bash. So I don't think I need anything else here. I don't need any environment variables. I don't need to do any port exposes as well. So let's just run this command, and we should just get a bash interactive prompt here in a moment. Sure enough, there it is, and we should be able to run the MySQL CLI utility. So there it is, it's pre-installed. And so now we're running in a second pod over in our namespace here called net policy. And so you can kind of pretend that it's one of these pods right up here representing some kind of client application. So now we need to connect over to this MySQL server pod. And in order to do that, we already know what the root password is because we set that in the previous video using an environment variable. But we can figure out the IP address of this pod and connect directly to it using that IP. So let's find out what that is. I'm going to fire up another tab in my terminal here, and we'll just do a kubectl describe pod MySQL server again. This is what we used earlier to verify that the labels were correctly applied here. So we'll just grab the IP address from that pod, copy that to our clipboard, and come back to our interactive MySQL client pod here, and then we'll run MySQL -- host, and we'll just paste in the IP address there of the target pod that we want to connect to. We also need to specify our user, which is going to be root, and then we'll specify the -- password option here as well, and that should prompt us for our password. Sure enough, there's our password prompt. I'll type cbt123, and as you can see, we are able to successfully connect from our client app called MySQL client out to the MySQL server pod here. So of course we expected that to happen because by default, again, pods have free reign to communicate with other pods in the Kubernetes internal network. However, what would happen if we were to attempt to implement a network policy that blocks traffic from pods that don't match our desired labels? Well, I'm going to switch over here to my other terminal here where I can just run kubectl commands, and I'm going to do a kubectl get pod. So this is going to show us the client and the server pod running in our net policy namespace. Sure enough, here they are. And what we want to do is basically create a network policy that allows the MySQL client pod to communicate with the MySQL server pod on TCP 3306. And you might be asking yourself, well, why do we need to do that? We already can communicate that way. Well, when we instantiate this network policy rule and apply it appropriately using the labels for the MySQL server pod, and then allow the labels from MySQL client pods, that's going to automatically block any other non-matching traffic from communicating with this server. So rather than having a default of allowing all traffic, we could actually apply a network policy and therefore block traffic from any pods that are not authorized. All right, so let's go ahead and apply a label to our client here that we'll use in our network policy. I'll do a kubectl here, and we'll say label, and we'll say pod/MySQL client, and I'll say purpose equals, how about DB client? All right, so we'll run that, and then we'll do a kubectl describe on pod/MySQL client. So now we should have a custom label on MySQL server, as well as a custom label on MySQL client. So sure enough, there's DB client as the purpose. So let me just copy that and bring that over into our diagram here so that we have some consistency between our diagram and what's actually on our cluster. So now we have these two different labels, and we can use these inside of our network policy. So in our next video, we'll go ahead and actually create the network policy now that we've confirmed that these pods can communicate with each other and we have applied the appropriate labels to them. I hope this has been informative for you, and I'd like to thank you for viewing.